So here we are talking about the waves and the waves properties. We need to know what is a wave, it just consists of, and what is it forming, what is the property for it. So if you need to know the all properties for the waves, we need to study the nature of the wave itself. So first of all, when we able to see, that's because the light coming from sun to earth, and once the light coming from sun to earth, it's moving as a shape of a wave. How does it travel? Like my sound, how do you hear my sound? How is it travel to you? How is your response is traveling to me? This is all moving in a shape of wave. So what does that mean by wave? So in this case, we can call the wave, which is anything, any particle that is disturbed in its place. For example, guess you are having a pond that filled of water, and this pond you throw a stone in. Once you throw a stone in, so this is making circles, circles, and become wider and wider. So in this case, it made it or forming a wave. So light also is a types of wave. That's why, because it can travel through space or it can travel through all mediums we know. So in meaning, what does it mean by a wave? The wave is a disturbance that's happening in a medium, and this disturbance carry or transform the energy from a place to another place. So when we got a wave, know that why do I study the wave? We do study the wave once it carry the energy and transfer it from a place to another place. So actually, this is the main mission for the wave, and that's what helped light to travel us to the earth once it carried the energy of the light energy and heat energy from sun to the earth. So the main mission for the wave is that it carry the energy and of the light energy, transfer it from the sun to earth. That's why we have a wave. Another thing in water waves, look at these water waves. Once this swimmer is just making here, give it energy to these particles. That's why it moving and transfer the energy to another place. So some waves with a difference between my sound when I'm talking to you and the light that is shining in the ebony space. Actually, the astronauts cannot talk in space. Why? Because they no medium to carry the waves particles to help it transfer, and that they depend on the light. Once the light, which has like can easily transfer through anything around, that easily transfer through, even you have a space, even you have particles of medium, even you don't have. So there's difference between these two types of waves. The first type of the sound wave that we only can hear us in the ground. I mean, like we hear us while there is air particles. You know why? Because the energy that is moving from my mouth to your ears, it's a wave, but it carry or it needed to be carried on medium to transfer it, need something to carry it. And these things that is carry it, which is the light particles. So your voice can transfer through the air particles from a place to another place. So this is happen in the waves or the types of waves, which is called longitudinal waves. Another types of waves, which is like a light waves or electromagnetic waves, which is doesn't require any medium to travel through. Once the sunlight can reach it to Earth, passing through the space, that's why it doesn't need medium to travel through. So the light waves doesn't need some medium to carry it. It doesn't need anything to carry to help it to transfer, as the opposite of our sound. So the waves that is don't need any matter or don't need any medium to carry it to transfer, and it also can transfer by its own, we can call it electromagnetic waves. And some another, you must have the waves that can carry with, you must have a medium that carry the waves and transfer through, which is the mechanical waves. So the types of waves, we have two types of waves. The first one, which is called transverse waves, and those waves which is help the waves moving perpendicular to the direction of propagation, like that part, like you got a tie a string and then hold it from the other end of it and try to move it up and down. This way has the same shape of the transverse wave. Like that, if you're going up and down, curve up and down. The highest point here, this is called the crest, and the lowest point here calling trough. So here, the transverse wave, it has here above crest and below the least point down, which is trough. So what does it mean by crest and trough? Listen here, this is the wave and this is the point of start point of it. So in that way, we can say like it's a highest point away from the wave to up, or it's called a crest, or it's a lowest point down to the wave, and this is called a trough. Another one, longitudinal waves, which is like the moving or vibrations happening as parallel to the medium. How is it parallel? I mean, in the same direction. Actually, it's not up and down like that part, but is like longitudinal. I mean, like parallel, moving, come forward, backward, and like that. And this one is consists of two main parts. Compressions, once you see like there's much density or much crowdness for particles in an area. And another place which when you have here, which is called the rarefaction. So we have two main things, the compressions and rarefactions. And then this is its way in motion. I mean, like many crowded place and a very empty place, very busy part and very empty part. So this is called the very busy part. This is called the compression. Like here you see crowdness of the particles, and here we got have like not crowded. It's like somehow empty. This is called a rarefaction. So the particles are so close together in the compression or crowded together, no more spaces, no intermolecular spaces between each other. While rarefaction is just made of the spreading out, or this parts is spreading and propagating all places we have. We call the compacted one compression, and we call the spreading out particles area rarefaction. So what is the properties for it? The first thing we need to discover the waves and study it actually to improve the transferring for energy from a place to another place. And we can control its speed, like the radio. Sometimes you see the radio moving or speaking so fast, and on other times you see it like speaking less. So in that case, we can call it a wavelength. What does it mean by wavelength? Wavelengths, if you got a wave like this, we call this as a crust, and the other part crust. The distance between two recessive crusts, I mean like the two following crusts or the two following troughs. This is called a wavelength. So the wavelength, it means like we got a distance between two recessive or consecutive crusts and two recessive troughs. Also here, the distance between two following compressions or two following rarefactions, if you are talking about the longitudinal wave. Next one, we need to know about the frequency. Listen to you, sometimes you see on the devices or electric devices, something written like 60 hertz or 60 Hz and 50 Hz. So in this case, this is mean like the number of waves that they can vibrate in 1 second. Again, the number of waves that they can vibrate in a 1 second, this is called the hertz. So for example, if I told you that we got a frequency, so you can count the waves, for example. If I told you in this one, I have in this wave, it passed through 10 seconds. And then I want to know its frequency. All what you have to do, just count how many waves we have. From here, this is called the start point, up, down. So here we got one wave and up, going back again to the start point. Again, how to count the waves? From here, we do have a start point, going one crest with one trough, going back again to your first point or your start point here to be one wave. Again, first point or start point or origin, anything, and then one crust, one trough, going back to the origin. This is called a one wave. So how many waves do we have here? Actually, we have one and then two. So in this case, I got two waves. What's the number of waves now? It's just two waves. It's equal two waves. And then in time passed through, which is, for example, 10 seconds. Actually, the time always calculated by the seconds. And then to find the frequency, we can make it like number of waves over the time, which is going to be equal to waves over 10 seconds. So in that case, we can call it like it's 1/5. And this is Hz, hertz. So with this way, we just calculated the number of frequency, the frequency which is equal fifth of the hertz or fifth hertz, which is mean like the number of waves through time, it's equal 1/5. Got to understand it?